Hello learners, I am Dr. R.B. Malati, Assistant Professor, Chhattisgarh Swami Vivekananda Technical University, Bhilai. I welcome you all again to the course Fundamentals of Building Construction. In our last class, we walked about the basics of stair and staircases. We covered definitions, the importance of stair location in homes and public buildings, and the need for fire resistant materials to ensure safety. We also discussed how to design stairs so they can bear specific loads and have comfortable dimensions like width, flight length, pitch and headroom. We covered key terms like tread, riser, flight and landing, and looked at different types of stairs and steps also. I hope this gave you a good glimpse on stairs and that you understood something about from our discussion. Today, we will read on stairs and staircases, dimension and geometric designs of staircases. At the end of this lecture, you will gain knowledge of the different materials used for building stairs and you will be able to confidently plan a stair for any buildings. Let us start with the different materials used to build stairs. The types of materials used for stairs are timber, stone, bricks, steel and reinforced cement concrete, shortly known as RCC. First, let us talk about timber stairs. Timber stairs are lightweight and relatively easy to construct, which makes them a popular choice for many. However, there is a big quant. They have very poor fire resistance. Because of this, timber stairs are typically used only in small rise residential buildings and are unsuitable for high rise residential buildings or public buildings. Sometimes, to improve the fire resistance, hard woods like oak or mahogany are provided because they have proper thickness. And you should make sure the timber that is used in stair construction should be free from fungal decay and insect attacks, and it should be well treated before use to ensure its safety. Let us look into the structure of the timber stair, that is 1. The stringers, 2. The step, 3. The landing. Kindly look at the figure closely. In the structure of the timber stairs, the stringers, that is the sides of the stairs, serve as a primary support and act like inclined beams spanning between the floor and the landing. For additional support, a bearer or carriage may be placed under the threads. In timber stairs, typically one bearer is provided for a 90 cm wide staircase and an additional bearer is added at every 40 cm increase in width. The thickness of these strings usually ranges between 3 to 5 cm and their depth can be between 25 to 40 cm. This setup helps in ensuring the stability and durability of the staircase. After strings, the next thing that we have to speak about is steps. The part you step on, called the tread, should be at least 32 mm thick, that is about 1/4 inches, similar to the thickness of your hefty book. And the riser, which is a vertical part between each step, should be at least 25 mm thick or nearly 1 inch. Typically, these threads and risers are connected using tongue and groove joints, much like your wooden floorboards fit together, and then they are nailed or screwed in place. Next, let's talk about the nosing in this, which is the front edge of the step. This should not stick out more than the thickness of the thread to prevent tripping. For a bit of extra style, you can even add squash blocks. Remember, we discussed the definition in the last class. Yes, those are the small curved pieces you might see at the base of a bookshelf or cabinet to make it look quite nicer. Moving on to the stringers, these are the inclined beams that support the steps, like the backbone of the staircase. They are typically 30 to 50 mm thick and 25 to 40 cm deep, which is about the depth of a wide drawer. Stringers can be supported on newels, trimming joists or pitching pieces much like how shelves might be supported by brackets or beams. And there are 4 main types of stringers. Kindly have a close look at those figures: cut strings, house strings, rough strings and weathered strings. First, cut strings. Cut strings have their upper surface cut to fit the thread and the riser precisely, much like how a jigsaw puzzle fits together. This makes the stairs look elegant, but just like a jigsaw puzzle pieces, this can be delicate and these cuts make them stringers a bit weaker. So, next, the housed strings. House strings have grooves cut into to hold the thread and the riser. These grooves are like slots in a wooden spice rack you see in your kitchen, where each spice bottle fits perfectly. The threads and the risers are nailed, glued and wedged into place for a tight fit. You can imagine using small wooden wedges dipped in glue to secure everything, much like how you might use wooden pegs to hold parts of your bookshelf together. Then comes the rough strings. Rough strings are used for wide steps and have rough brackets underneath, similar to how a wide bookshelf might have extra supports underneath to keep it sturdy. Next, the final one, the weathered strings. The weathered strings are curved stringers like the graceful curve of a spiral notebook. These can be either cut or housed. That ends the 4 main types of stringers. Let us now talk about landings, the flat areas where the staircases change direction. These are constructed from tough and grooved boards on timber joists, like the sturdy floorboards in a room. For a half-space landing, a timber joist spans the full width of the staircase, kind like a wide plank bridging 2 points. For a quarter-space landing, a timber joist called a pitching piece is placed in the wall at one end and housed with newel at the other, much like a sturdy beam supporting a shelf on one end and attached to a wall on the other. Hope you could visualize all these from the figure. Let us take a quick recap now. Timber stairs are light and easy to build but not fire resistant. They are suited for small rise residential buildings. Hardwoods like oak or mahogany can be used to enhance fire resistance. The timber should be free from decay and it should also be well treated. Strings act as a main support spanning between the floor and the landing. Additional support can be provided by bearers. Thickness of the string is said to be around 3 to 5 cm and the depth of the strings has to be around 25 to 40 cm. Remember, while timber stairs have their own limitation, with the right treatment and proper materials, they can still be a beautiful and functional choice for many buildings. Alright, that's all about timber stairs. Let us move on to the next material, that is stone. Stone stairs are quite popular in areas where ashlar stone is quite available. What is ashlar stone? Ashlar is a cut and dressed stone worked using a chisel to achieve a specific form. They are typically rectangular in shape. Stone stairs are incredibly strong and rigid. Although they can be quite heavy, it is important to use hard, strong, wear-resistant stones for building these stairs because they need to withstand a lot of use, and the good thing is they are fire-resistant too. Now, a simple question for you. Why do you think it is important for stones used in stairs to be wear resistant? Give a thought. Yes, the answer is stones need to be wear resistant because stairs are subject to constant foot traffic, and over time this traffic can cause wear and tear, especially on softer material. So, by using wear resistant stones, we ensure the stairs remain durable and maintain years of use. Moving on, the simplest form of stone stair is the kind supported on both ends. But we can also build open well staircases. In places like Jodhpur, dog-legged stairs with cantilevered spandrel steps made of sandstone are quite common. While visiting Jodhpur, don't forget to click a picture of it. There are several types of stone steps you might encounter. And the first one is rectangular steps with rebated joint. These are the simplest. Imagine using a large rectangular blocks of stone stacked with front edge of one step resting on the back edge of the step below it. Sort of like how you might stack books slightly overlapping each other. That is how a rectangular step with rebated joint looks like. Spandrel step. These steps are nearly triangular in shape, which gives them a neat smooth underside called the soffit. Each step is squat built into the wall at the end, giving a pleasant appearance. Think of it like the neatly stacked layer of a cake. Very beautiful, isn't it? Now, a question for you again. What makes a spandrel step different from a rectangular step? Think and answer. Yes, spandrel steps are triangular in shape, allowing for a plain or decorative underside soffit, while rectangular steps are simple rectangular blocks. The triangular shape of the spandrel steps not only provide a different aesthetic but also enables a tight fit against the wall, enhancing the overall appearance of the staircase. Then comes the third one, that is tread and riser steps. Here, flat stone slabs are used as both the tread, the part you step on, and the riser, the vertical part. These can be connected through dowels, much like how you might use pegs to connect pieces of furniture. The thickness of these slabs can vary from 5 to 8 cm, as similar to the thickness of your heavy textbook. Next, the cantilever thread slab steps. These steps are made only from the threads without any riser. The thread slab is fixed at one end into the wall and act as a cantilever, much like a diving board. Yes, similar to that springy plank you see at your swimming pool, which people use to dive into the water. These steps can be rectangular or triangular in shape. Built-up steps. In these, thin stones or marble slabs are used as thread and risers, placed over brick or concrete steps. The thickness of these slabs ranges from 2 to 5 cm, kind of like a thick magazine. Okay, let's pause now. A question for you. Can you think of an advantage of using built-up steps over solid slab steps? I'll repeat. Can you think of an advantage of using built-up steps over solid stone steps? Yes, what can be the answer? Of course, everyone thought it right. The advantage of using built-up steps is that they combine the strength of underlying brick or concrete with a beautiful upheaval of stone or marble slabs. This makes them lighter and more cost-effective than the solid stone steps, while providing the desired look and durability. So, from this we can understand that each type of step has a unique feature and benefit, allowing for a range of design options suited for different architectural needs and personal preferences. Yes, let's move on to the next material, that is brick stairs. Imagine walking up to a quaint village house with a sturdy brick stairs leading to the front door. Brick stairs are commonly seen at entrances because they are durable and blend well with the traditional architecture. However, they do need regular upkeep due to weathering. To splash them and make them last longer, some homeowners face them with smooth stone slabs or apply a protective cement paste on it, which you have noticed often. Now, let us move to the next type, that is a metal stairs. Have you ever been inside a busy factory or warehouse where you might see those sturdy metal stairs leading up to different levels of emergency exits? Yes, these stairs are typically made of iron materials like mild steel or cast iron, which makes them ideal for industrial settings where durability and fire resistance are important. However, they are less common in homes or public buildings because they can be quite noisy when people walk on them and may not fit the beautiful preference of the residential users. Okay, let us explore next the RCC, reinforced cement concrete stairs. Imagine you are walking into a modern apartment building on an office complex. chances are that you will definitely encounter RCC stairs, those strong fire resistant stairs that are crucial for both safety and beauty. There are two types of it. First is the horizontally spanning slab and the next is the slab spanning longitudinally. To understand the first type, please visualize a stairway where the steps are like small beams. In this type of design, the slab that makes up the stairs is supported on one side by a side wall or a stringer beam and on the other side by another stringer beam. Sometimes, especially with straight stairs, the slab can be supported horizontally by a side wall on one side of each flight and a common nivelle on the other side between the backward and the forward flights. Now, let us talk about how we figure out how much weight each step can hold and how we design this horizontally spanning slab stair to strong enough. First, we need to understand the effective span L, which is the horizontal distance between the center of the support. This is important because it tells us how far the step spans between the points where it is supported. The key formula we use to determine the bending moment, which is a measure of the force that can cause a step to bend, is WL square by 8. Here, W is a uniformly distributed load on the step, which includes the weight of the step itself and anything else that might be on it, like people or furniture. Think of it this way: you are holding a stick by its ends and placing weights along its length. The bending moment is a measure of how much that stick will bend under the weight. For stairs, each step acts like the stick, and we need to calculate the bending moment to ensure the step won't bend too much under the load. Each step is considered like a rectangular beam, with its width B being measured parallel to the slope of the stair and an effective depth equal to d by 2. This is like you were to slice the step in half. The depth we consider for strength calculation is half of that slice, as simple as that. Okay. We then add reinforcement to make sure the steps are strong. The main reinforcement, which is stronger, thicker steel bars, are placed in the direction of L, the span. The distribution reinforcement, which helps distribute the load more evenly, is placed parallel to the direction of the flight. Finally, we add a waist of about 8 cm to the stairs. And this is like adding an extra layer of strength at the base of each step, ensuring the entire structure is robust and can handle the daily wear and tear. So, to summarize between, you need to know how is a span, how much weight it will hold, that is a load, and then you reinforce it with the steel bars to ensure it doesn't break or like deflect. Thus, by carefully calculating and reinforcing each step, we ensure the stair is safe and strong for everyone who uses it. A question for you right away here: where is the main reinforcement typically placed in longitudinally spacing RCC stair slab? And the options here are A, along the sides, B, parallel to the flight direction, C, at the center, and D, perpendicular to the flight direction. Think twice, what can be the answer? Yes, the answer is B, and the reason is stress is distributed in that particular direction. Let's talk about another type of stair, 2, where the slab spans longitudinally. In this setup, the slab is supported at the bottom and the top of the flight, but the sides remain unsupported. Imagine a stairway where each flight is continuous and supported by beams at the top and bottom or on landing. When supported on landing, these landings become part of the slab itself. A typical example of this is the dog well stair as shown in the figure. Here is how we reinforce the stairs. Main reinforcement, which is stronger steel bars, is placed parallel to the direction of the flight. The distribution reinforcement, which helps to spread the load more evenly, is placed along the width of the slab. Now, sometimes for the wider stairs, we add a central stringer beam. This beam spans between the end walls or columns supporting the stair slab, also known as the waist slab. The waist slab is designed to cantilever out on both the sides of the stinger beam, meaning it extends outwards. Additionally, the stinger beams itself is designed as a T-beam, giving it additional strength and stability. That is all about RCC stairs. Now, for a touch of architectural elegance, consider helical stairs, which is the next choice. Helical stairs are those graceful spiral designs you might see in modern building or luxurious home. These stairs are cast in site, meaning they are formed on site with a complex arrangement of steel reinforcement to handle bending, shear force and torsion. The thickness of the RCC slab varies along its spiral shape, adding both strength and stability. I assume you are now familiar with the concept of bending, shear force and torsion. If not, please refer to the end portion of our last class lecture for a detailed explanation. Now, another question for you right away here. What is the distinguishing feature of a helical RCC stairs? Options here are: they are cast off site, they are unsupported along the sides, they require less reinforcement, or they have a spiral shape. Finally, and it is for you to find out the answer and give it on the comment box. Yes, now precast concrete stairs. They are widely used today for the efficiency and quality, as they are manufactured in a factory and then transported to the construction site ready for installation. There are three common types: rectangular cantilever steps, which project out without additional bracing; spandrel cantilever step, which fit seamlessly within the architectural space and are often seen in grand staircases; and sector shaped cantilevered unit, used for creating open rise spiral stairs fitted together to form a spiral. And these designs ensure strength and stability with bending moment carefully calculated to prevent bending. Using precast units speeds up the construction and ensures uniformity, making them a popular choice these days for modern buildings worldwide, such as airports and shopping malls. Let us now walk through the planning of the dog-leg stair for a building where the vertical distance between the floor is 3.6 meter and the stair hall measures 2.5 meter by 5 meter. So, the problem statement is like this: plan a dog-leg stair for a building in which the vertical distance between the floor is 3.6 meter. The stair hall measures 2.5 meter by 5 meter. First, let us understand the requirements and dimensions we are working with. So, the step 1 is, let us jot out the details given in the question. That is, the vertical distance between the floor, that is 3.6 meter, stair hall dimension is 2.5 meter by 5 meter, and now we need to assume some values. First one is the rise R, which is 15 centimeter, thread T 25 centimeter, width of the each flight 1.2 meter and width of the landing is 1.2 meter, which is generally equal to the width of the stairs. Next comes the step 2, that is determining the height of each flight. Since given the question it is dog-legged, it will have 2 flights of stairs with a landing in between. Therefore, the total height of 3.6 meter will be divided equally between the 2 flights. Hence, height of each flight is 3.6 meter by 2 is 1.8 meters. Third step, calculating the number of risers. The number of risers, that is the steps, required for each flight is calculated by dividing the height of each flight by the rise. So, the number of risers per flight is equal to 1.8 by 0.15 is equal to 12. Next, the step 4, calculating the number of threads. The number of threads, that is the horizontal step, is always 1 less than the number of risers because the topmost riser leads to the landing. That is why number of thread per flight is equal to number of risers minus 1. That is 12 minus 1 will give 11. Coming to the step 5, that is calculating the space occupied by the threads. The space occupied by the thread is calculated by multiplying the number of thread by the thread T value. So, space occupied by the thread is equal to 11 threads multiplied by 0.25 meter is equal to 2.75 meter. Step 6, determining the remaining space for passage. Finally, we calculate the remaining space for the passage in the stair hall. This space is the total length of the stair hall minus the width of one flight and the space occupied by the threads. Therefore, the space left for the passage is equal to 5 meter minus 1.2 meter minus 2.75 meter, which gives 1.05 meter. Summary of the plan. For a building where the vertical distance between the floor is 3.6 meter and the stair hall measures 2.5 meter by 5 meter, we can provide number of rises per flight is 12, number of thread per flight is 11, space occupied by the thread is 2.75 meter and the space left for passage is 1.05 meter. Let us walk through another beautiful example on the design of suitable stair for a public building with a stair hall measuring 4.25 meter by 5.25 meter and a vertical distance between the floors of 3.9 meter. So, the problem statement is right here. Figure shows the plan of a stair hall of a public building which measures 4.25 meter by 5.25 meter. Please see the vertical distance between the floor is 3.9 meter. Design a suitable stair for the building. Okay, first let us jot out the details given in the question. Step 1. Given data, stair hall dimension is 4.25 meter by 5.25 meter. The vertical distance between the floors 3.9 meter. Now, we need to assume some values. So, the assumed values are rise R 15 centimeter, thread T 25 centimeter, width of each flight 1.5 meter because it is a public building, typically requires wider stairs for safety and ease of use. The last problem we kept it as 1.2 meter as it is a residential building. So, the width of the building is equal to the width of the stairs. Step 2. Determining the space between the flights. Given the width of the stair hall, we need to calculate the space between the two flights of stairs. Kindly look into the figure for clear understanding and follow the steps simultaneously. The space between the flight is equal to 4.25 meters minus 2 times of 1.5 meters minus 4.25 meters minus 3 meters is equal to 1.25 meters. This space is sufficient to provide an open well stair, which means the space between the two flights is open. Step 3. Calculating the number of rises. The number of rises, that is steps, required for each flight is calculated by dividing the height of each flight by the riser. Number of risers is equal to 3.9 meter by 0.15 meter is equal to 26. Step 4. Calculating the number of threads. The number of threads, that is a horizontal step, is always one less than the number of riser because the topmost riser leads to the landing. So, the total number of thread required, number of thread minus 2 is equal to 26 minus 1, which gives 25. Step 5. Dividing the riser and thread. Since the maximum number of thread in each flight for public building is limited to 9, we need to design the stairs accordingly. Each flight will have 9 threads and the remaining threads will be accommodated in the landing portion. So, the step 6 is allocating threads in flight and landing. Number of threads per flight is 9. Remaining threads to be accommodated in the landing is equal to 25 minus twice of 9, which gives 7. So, the step 7 is calculating the horizontal distance for thread. Width of each thread T is 25 centimeter. So, the horizontal distance required for thread in each flight is given by 9 into 0.25 meters equal to 2.25 meter. Step 8. Calculating the width of the passage left. Width of the landing is 1.5 meter, which is equal to the width of the stairs. Total horizontal distance required is equal to 2.5 meter for thread plus 1.5 meter for landing minus 3.75 meters. So, width of the passage left is equal to 5.25 meter minus 3.75 meter, which gives 1.5 meter. Summary of the plan. Stair hall dimension 4.25 meter by 5.25 meter. Vertical distance between the floor 3.9 meter. Width of the stairs is 1.5 meter. Height of each riser is 15 centimeter. Width of each thread is 25 centimeter. Number of riser 26. Number of threads 25. 7 in the landing portion and 9 per flight. Horizontal distance for thread is 2.25 meter for flight. Width of the landing is 1.5 meter. Width of the passage left is 1.5 meter. I hope you found today's class informative. Let's end the class with a note. Stairs may seem like a small part of a building, but they play a big role in its safety and functionality. So, choosing the right materials can make all the difference. Thank you for your kind attention. Looking forward to seeing you in the next class. Happy learning.